Hello folks, we are going to talk about TCP and UDP ports. What we are looking at here is an expanded view of two of the layers of TCP IP stack. So first off, we have the transport layer, and then right above that we have the application layer. Now in a previous cast, we discussed some of the application that make use of the transport layer and their port number. So in this example, we are visually showing you the TCP and UDP port number that are used to support different conversation between networking devices. So what you will notice in this application is that if you are going to recognize, analyze, and be able to report accurately on the different attack that you see an analyst, you are going to need to know which application use TCP and which application use UDP as their transport. And you are going to also need to know the post that they use. Now IANA control the port number. Some application that we use quite often have assigned dedicated port numbers, and that's what we see here. For example, FTP is assigned TCP port 21. More specifically, it assigned both TCP and UDP port 21, but the application itself make use of TCP as its transport layer protocol. The same is true with Telnet and HTTP. We have TFTP and SNMP discussed previously, and those make use of UDP as their transport mechanism. The ports number that are assigned to those applications are UDP port 69, or more specifically just port 69, and port 161 for SNMP. SNMP is also assigned port 162. Now in most cases what happens is we have a server, and that server is running a daemon on it. Now the daemon listens on one of these port numbers when a client application try to connect it. It is assigned what known as the ephemeral port, which is a high number port that is dynamically selected and that is used as the source port, while the destination port it try to connect to will be one of these well-known port numbers, again depending on the application. The port number are defined in RFC 1700. The ephemeral ports are port number that are above 1023, but we typically see them in the 65,000 range. Anything that is numbered 1023 and below is considered a well-known port by IANA. One application here, DNS, make use of port TCP and UDP for its transport. It is assigned port 53, and it depends on how the application is used as to whether it will be TCP or UDP based. Again, having a good understanding of TCP ports and how they are used will make a difference for you acting as analyst and being able to report the different application attacks. Being able to do that accurately, being able to recognize them, and really being able to analyze them. In this example, we have server number 1, which is running a daemon that is offering web services. A user, client A, client B, or client C is going to establish a connection to the web server. So what happens is, as the TCP segment is created on client A, B, and C, the destination IP address will determine that will be done using DNS. We know that we are making an HTTP connection because of the application that is in use on the client computer, and so it will select port 80 as its destination port. It is going to select an ephemeral port, a high number random port, as its source port number, and it will go ahead and make that connection. So as the TCP segment travel from client A to server 1 receives that connection request and has to go through the three-way handshake. Now you remember, with that three-way handshake there is a reply that come back. We call that a SYNCAC. The SYNCAC is going to be directed to that ephemeral port that client A selected, port 49,741 in this case. So in the return packet or the return segment from server 1, it will have a destination address of 10.10.10.10 with the destination port of 49741, and the source address will be 10.99.99.0 with the source port of 80. So right now we have this server and it is handled 3 sessions at the exact same time, and that is not a problem. These three sessions are distinguished by 5-tuple information. 5-tuple information include the local IP address and the local port as well as the protocol. So the protocol would be HTTP, the remote IP address, as well as the remote port. So this differentiate between each of these three sessions. Now in this example, client A and client C are using an identical ephemeral port 49741, but because of the 5-tuple information, their source IP address is different, and the server can maintain a unique session for each of these devices. So this is all from TCP and UDP ports. Next, see you in address resolution protocol.